Hi class, this is section 6.3. This is one of my favorite sections in this whole book. So let's get started. The first thing I want to remind you about is what an inscribed angle is. So angle CAR in this picture here is an inscribed angle because the vertex of the angle lies on the circle. You can see here that angle COR is a central angle, and both of these angles have the same intercepted arc CR. So that's something that you're going to want to look at when you're looking at pictures and solving problems. So our first couple conjectures have to do with inscribed angles. And you can see it says the measure of an angle inscribed in a circle blank. So we need to fill in the blank. So let's open up Sketchpad and get started. So we're going to construct a circle, and we are going to make an inscribed angle. So I have the 1 point on the circle, and I'm going to make 2 more so that I can construct an angle. So I've made a chord there, and now I'm going to make another chord. So that I have an inscribed angle. Now we're going to do some measurements here. So I'm going to measure this angle. And then I'm going to measure its intercepted arc. So if you're curious about what the intercepted arc is, follow the angle out to its endpoints, highlight the 2 points in the circle, and say measure arc angle. So what is the relationship between these two things? Now I could make the central angle, and we can look at it. Okay, so now I'm going to measure angle CDA. And we've already talked about how the central angle is the same measure as its intercepted arc, but what about this inscribed angle? So I am going to go to the calculator and see what the relationship is. So if I take angle ABC and I multiply it by 2 or double it, look what I get. So you can say either the inscribed angle is half the measure of its intercepted arc, or you can say the intercepted arc is double the inscribed angle. So it's equal to the central angle, but double the inscribed angle. So let's take a picture of this and put it in our notes. Before we go back and write some conjectures, I want to look at one other thing. I am going to put another point on the circle and construct another angle. So now I'm going to connect point C to this point. That's going to be called probably point E. Notice that it has the same intercepted arc. I could slide this around and it doesn't matter. It stays with the same endpoints. So point or angle B will be the same measure as this angle because they have the same intercepted arc. But let's measure it just to make sure. So these two inscribed angles have the same intercepted arc, which makes angle B congruent to angle E. Okay, let's go write some conjectures. So the first one, the measure of an inscribed angle inscribed in a circle, I'm sorry, is 1/2 the measure of the intercepted arc. The measure of an angle inscribed in a circle is 1/2 the measure of its intercepted arc. So there's our picture to go along with it. Our next conjecture, inscribed angles that intercept the same arc are congruent. And here's the picture that goes with that one. Won't let me slide it. Okay, so let's go on to the next one. Angles inscribed in a semicircle. So let's go back to Sketchpad and see what happens if we make a semicircle. So let's start with a new circle. In order to make a semicircle, we're going to have to do a diameter. So I am going to highlight these 2 coordinate points, unhighlight the circle, and construct a line. So if I make a line that goes to those 2 points, I know it's a diameter, which makes a semicircle. So I'm going to highlight this other intersecting point. I'm going to highlight the 2 points there and go ahead and make that a segment. So that is my diameter, and then I can hide my line. So I have a semicircle. Now I'm going to put a point on the circle and make an inscribed angle that has its endpoints that lie on the ends of the diameter that I have constructed. So I want to construct a segment there. Then I want to construct a segment here to make my angle. And there we go. Now, so we have this inscribed angle. Look at its intercepted arc. What is the measure of its intercepted arc? If the whole circle is 360, that means half the circle is 180. So if I take half of 180, then the measure of my angle will be 90. So let's just measure it to make sure. And there it is. So if you look for the diameters of a circle, you should be able to find right angles. And look, I can slide B wherever I want it to be, and it stays a right angle because its intercepted arc will remain a semicircle. Okay, now while I have this picture up, I'm going to go ahead and move into the next conjecture, and I am going to put another point on the circle, and then I'm going to construct a quadrilateral. I can hide the diameter for this one. And I have a 4-sided figure, which we call a cyclic quadrilateral because all 4 vertices lie on the circle. Now, let's measure the angles and see what happens here with our cyclic quadrilateral. So I'm going to measure angle A, then I'm going to measure angle D, and then I'm going to measure, angle C. So we already know that all 4 of these add up to be 360 because it's a quadrilateral. There's another relationship. The opposite angles are supplementary. Now we already know that these two are 90 and will remain 90 because of the way we constructed it. But if we look at our calculator, we can see that if we take angle A and add to it the angle across from angle A, which is angle C, that they are indeed supplementary. So cyclic quadrilaterals are supplements of one another. The opposite angles are supplements of one another. Okay, so let's go and complete our conjectures. Angles inscribed in a semicircle are right angles. Conjecture 62. And there's the picture to go along with that. And then we have the blank angles of a cyclic quadrilateral are blank. Now make sure that you get the definition of cyclic quadrilateral into your notes. So a quadrilateral inscribed in a circle is called a cyclic quadrilateral. Okay, so let's fill this in. We now have cyclic quadrilateral in our notes. So the opposite angles of a cyclic quadrilateral are supplementary. Okay, the opposite angles of a cyclic quadrilateral are supplementary. Okay, we have one more conjecture. So we want to start with a new sketch. We're going to start with a circle, and we are going to make parallel lines. Oops, don't need another circle there. So I am going to put another point here and go ahead and construct a line segment or a chord, as it's called in a circle. I'm going to put another point down here, and now what I want to do is construct a line parallel. To that line. So I want to find the fourth point there that hits the circle. Then I can construct a chord. So I have two chords in my circle that I know are parallel. Okay, if I move this, notice my lines stay parallel. I can change the size of my circle by moving this point. But no matter what I do, my lines stay parallel. So here we go with our two parallel lines. Now what do the parallel lines do? So I am going to highlight the 2 points, highlight the circle, and I'm going to measure these arcs. So arc CD has a measure of 68.75 in my picture. Let's see what happens when I measure this arc on the other side. I also get 68.75. So what happens is the parallel lines make congruent arcs. So you can see that no matter if I move the points around, my arcs in between the two parallel lines are congruent. So let's complete the last conjecture, and that's it for today. So take a picture of that circle, go back into your notes, Let's complete the last conjecture. Parallel lines intercept congruent arcs on a circle. So we just need to fill this in with the word congruent. I'll see you in class tomorrow.